Hi guys, in this video I'm gonna talk about peering use cases. What is peering? Peering is your Internet Gateway router connection to your Internet Upstream Gateway and now also to your Cloud Gateway. And I'm gonna share various peering use cases and challenges that you may encounter or want to accomplish to provide better service to your Internet and Cloud user. This video is part of Cisco Peering Fabric demo series. And my name is Hinwato. I'm a Cisco Technical Solution Architect, a CCDE, and a CCIE. You can get more information of Peering Fabric Network Automation. Just please sign up to ciscolive.com and access to the Cisco Live session, Intelligent Peering Fabric Network Automation Use Cases. There are complete slide deck and demonstration video. Let's have a look at this network. Initially, we may have single Internet gateway with single upstream link for our Internet user in our single DC. Life's good for the network engineer. It's a simple network and easy to manage. However, things will change. The business is running well and user number keeps growing, hence we need to build more resilient infrastructure and more redundant geodesy in the West region, as well as adding more network peering upstream link and Internet gateway to have more Internet capacity, redundancy, and traffic distribution. Now, the network becomes more complicated. More Internet and DC users want their own specific requirement and SLA, and we need to ensure that any Internet gateway policy changes can fulfill certain customer requirement only without global customer impact. Now, network engineer has more and more challenges to keep up this network complexity using manual way. Soon, SP has built more collocated Internet gateway in overseas IXP to provide better low latency link for Internet and cloud connection, adding more Internet upstream link as well as more network complexity that network engineer need to handle. Now, for network engineer, the growing network has become his growing pain. Sounds familiar, right? Next, I will talk about peering trend and peering use cases.
So currently the traditional content peering has evolved very rapidly and to become more direct connection between SP and the content provider. So more direct link, more peer links are established among IXP and among XP and among content provider. Yeah, it gives benefit for the SP, better lower cost, more predictability routing, better performance, and reduce the transit bandwidth. And it also gives advantage to the user. It can give more or lower latency there, higher reliability, and better performance. So according to the Internet Exchange map, in 1995, there were 20 IXPs, but now it has grown nearly 40 times. We currently have almost 890 IXP worldwide, and it keeps growing. And the multi-cloud now is the norm. So 85%, according to the IDC, the cloud adopter has started their journey. And then 58% of them, at least they start working with 4 cloud vendors, whether it's from the ISP, from SP, or from a public cloud. Now, the service provider has really more and more challenge in how they manage their Internet gateway so that they can connect the cloud, the specific customer in very granular, very flexible. And it will be the question, does your Internet gateway has the capability, has the flexibility, and has the automation capability to do so. So let's see the use case now. I'd like to see from the ingress policy, incoming traffic for the download traffic of the user. Assuming here we have the mobile packet core or the ISP subscriber, we have the customer preface here, ID Cloud and ID Cloud 1, and we would like to have the policy, the internet traffic comes to the ID Cloud, it will select the low-cost peer link, the AS8-1. And then for any internet traffic, for the incoming one, or ingress traffic, it will select the low latency peer link, the AS6. You would like to have a capability to control it very simple and very easy. And that is toward the subscriber on the DC here. And what about the other DC here? Let's say that we have the FTTH gateway, or this is another customer of the enterprise that we can set up the virtual gateway for this customer. So we would like to have a different policy for the incoming, and also the priority here for the ID Cloud 2 subscriber. We have 4 peer links options. We want to prioritize which one is the first, second, third, and fourth. And right. And another use case for the ingress related to the bandwidth utilization of the peer link. This is based on the telemetry solution. Here I use the Internet Gateway 6 as part of our SP network. The router 6 has 3 peer link options. 5 is a direct, and 8 and 7. Now, assuming that we have multiple traffic flow from this router 5, the internet router, coming to the subscriber on the router 6, then we would like to have the incoming policy or the ingress policy based on the bandwidth utilization. The gold customer and silver customer definitely start flowing through the direct link. However, once the upper threshold is triggered, you would like to have the policy to offload the silver customer traffic using the other peer link, but not direct, via 8 and 7, so that the gold customer performance will be very good. And then, after this gold customer traffic finish its flow, then the peer link, the direct one, is available. You would like to have the policy that makes the other silver customer traffic back to this direct link. It is using the lower threshold policy. Right. So this is based on the telemetry. Okay, now let's take a look on the egress, the outgoing, the upstream traffic from the customer. Still, we have so many destinations on the internet, to the public cloud, the entertainment apps, and the social media apps, right? So we would like to have very granular capability to steer from this customer towards the certain internet apps using certain peer link. To do so with the existing technology is very complicated. You need to define the BGP policy there, or even policy-based routing that will impact the performance. And also, if we select to make changes on the border internet gateway, it may also impact for every customer. And even though if we manage to steer the traffic up to our preferred internet gateway, we still have difficulty or no capability how to steer this certain customer using certain uplink. There is no capability. And then also, what happens if you want to have other gateway here on the other data center, and also to have very specific policy of egress? Now it becomes more complicated how to create a simple and straightforward policy for each gateway. As well as you would like to have the load share capability for the outgoing here. Let's say any traffic towards the Google, we would like to use this peer link from 7 to 8 and from 1 to 5 with different weight. This is 2 compare, and this is 1. And also, we would like to leverage our low cost and low latency peer link only for certain internet application or public cloud application, right? And also for certain customers. Here is similar to the prioritization on the incoming or ingress, and we would like to have it on the egress, outgoing traffic policy. Again, for certain subscriber or customer prefix only, and very specific gateway. Then, in case there is a gateway failure here, Gateway 4 already has its own ingress and egress policy, and the Gateway 4 fails. We would like to have the capability or automate a seamless gateway policy motion, move to the other gateway here, and having the same exact traffic ingress and egress policy in very automation manner. See, there are several use cases that we see that is very complicated, is very complex. Currently, we really rely on a manual configuration changes, and it will impact to the global customer, and we also may impact to the internet gateway performance because of the policy-based routing, and also complicated if you would like to have the network SLA based on memory utilization, like the telemetry use case there. See? So this is the summary of the use case requirement that I will share how to solve it and even demonstrate the solution moving forward. Ingress, egress based on low latency, cost, load share, and telemetry, resiliency, how to swing or move the gateway policy in very seamless manner, and this solution can start from the standalone internet gateway up to the distributed model, and it also has the open API in the rest. This Jack Wells quotation, I think, is very good. Control your own destiny or someone else will. In our case, control your own multi-cloud and peering traffic or something or someone else will. That's from the peering fabric network automation. So this is the additional peering resources you can revert to. Please take a look. It's very good document, very well documented, and very a lot of resource. I love this all blocks and the segment routing resource. Very good books from Clarence and Chris, which are segment routing books part 1 and 2. Looking forward to part 3 for the SR physics, as I know. And yes, please check my YouTube channel as well. I have recorded some segment routing use cases, as well as with the segment routing policy or path composition element and ESO in terms of the transport and VPN service and architecture of transport as well. I think later on I will add more video recorded there. And also the segment routing channel on the YouTube. Yeah, that's very good. I think, hope you get very useful this session. Thank you. Feel free to reach me for any update or for any concern. Thank you very much.